Hello everyone, this is Himanshi Gupta presenting my work through the poster entitled High-throughput virtual screening and enhanced sampling simulations, an integrative approach for identification of potential inhibitors for Huntington's disease. Huntington's disease is a rare, progressively worsening neurodegenerative disorder. The disease arises from the mutations in the polyglutamine tract in the Huntington gene, which leads to the production of mutant Huntington protein. Since the disease is a monogenic disease, therefore lowering the mutant Huntington level seems a promising therapeutic approach. GPR52, which is an orphan G protein coupled receptor, has turned out to be a novel drug target for slowing down the disease by lowering the mutant Huntington level. Therefore, the objective of this study is to identify potent small molecule inhibitors against GPR52. Coming towards the methodology, to start with, we selected the GPR52 PDB structure having the PDB ID 6LI0 from RCSB PDB data bank, and for the small molecule library, we have selected the Zinc 15 database. First, we performed the high throughput virtual screening of more than 2 lakh compounds. After the high throughput virtual screening, we filtered out the compounds on various filtering levels. It comprises binding affinity, the pharmacokinetic profiling, and the interaction analysis. After this, we perform the fast pooling of ligand simulations and umbrella sampling simulations of the shortlisted compounds. To perform the fast pooling of ligand simulations, we use the parameters of pooling velocity of 0.005 nanometer per picosecond and the spring constant of 300 kilojoule per mole per nanometer square, and run for 500 picosecond. While in the case of umbrella sampling simulation, each umbrella window was run for 5 nanosecond. These are the results. In this study, we have considered compound C43 as the reference compound along with our shortlisted hits compound 1, 2 and 3. These are the 2D structures of these compounds along with their chemical name. The compound C43 showed the docking score of minus 9.02, therefore the compounds which were showing the better binding affinity than the reference compound were selected. Now coming towards the molecular docking, this is the interaction analysis figure during the pre-MDS stage. The figure A shows the superimposition of all the compounds in the GPR52 binding pocket. And figure B shows the interactions in the compound C43, where we can see that it is forming the hydrogen bonds with threonine 303, while compound 1, 2 and 3 are also forming the hydrogen bonds in the same active pocket. Next, coming towards the fast pooling of ligand simulations. The figure 2 shows the force versus time plot during the FPL simulations. We can see that the compound 3, which is in the green color, is achieving the maximum force to unbind from the GPR52 binding pocket. The FPL simulations was performed to see the unbinding pathway of each compound. And after the compound 3, the next highest force was achieved by compound 1, followed by compound 2, and at last the compound C43. It shows that the compound C43 was weakly associated in the binding pocket of GPR52 as compared to our 3 selected hits. The figure 3 shows the ligand displacement versus time plot during the FPL simulations. This table shows the time taken by each compound to reach a fully solvated state where there was no bond observed between the compound and the protein. Here we can see that compound 3 is achieving the highest maximum force, which is 485, and the time taken was also the highest, 347 picosecond, while the compound C43 was having the lowest residence time with 122 picosecond. Figure 4 shows the interactions during the unbinding pathway in the FPL simulations. For example, figure ABC shows the interactions in the compound 1 at 0 picosecond, where the compound was in the fully bind state. It is showing the 3 hydrogen bonds, whereas at 150 picosecond the number of hydrogen bonds decreased, and at 279 picosecond, the compound was not showing any hydrogen bonds or any non-bonded interactions when it has reached the fully solvated state. Similarly, the analysis was performed for all three compounds. Next, coming towards the umbrella sampling simulations, it shows the free energy profile of the all compounds. The table summarizes the free energy profiles of the all four compounds. Here we can see that the compound 3 is achieving the lowest binding free energy of -20.82, and the reference compound was achieving the highest binding free energy. These results are in the agreement with the fast pooling of ligand simulations, where we showed that compound 3 was having the highest residence time, therefore having the strongest binding with the protein GPR 52. These are the umbrella histograms where we show that the overlapping of the histograms indicates the good sampling of the compounds. Now coming towards the discussion and conclusion, the GPR 52 shows a pivotal role in the disease, and the current study identifies the compounds 1, 2 and 3. The higher residence time and the rupture force of compound 1, 2, 3 was greater than the reference compound C43, which indicates that these compounds took longer time to unbind from the GPR 52 to reach a solvation state. The HTVS studies coupled with the simulations reveal the residues, these residues to play a key role in the inhibitory effect of the compounds. Hence, our study identified hit compounds that can be further explored.